Let's cover the Arnold render settings. I really like working with Arnold, and one of the reasons is due to the render settings. They will live under the Arnold render tab and under sampling. This is where we'll do the vast majority of our sampling. You can see we have only a few options to actually tweak, and unlike other renderers you might have used, this is really quite simple. I've used engines before where if you increased a certain number, render times will go down. You increase another number, render times will go up. So it's really quite confusing in other engines, and this is why I really like Arnold, because here you can see you have 3 and then you have 2 for everything else. So what does this actually mean? Well, if you see here, we have the number 3, but up here where it says camera AA, we have samples of 9. We have diffuse set to 2, but we have diffuse samples set to 36. So what's going on is that in order to get the samples we have up here, we have this number squared, which means this is 3 times 3. So now we have 9 samples. For diffuse, we have 2 times 2, which is 4, times this squared, this number. So in this case, let's do some quick math. So to get the first number, we have 3 times 3, which is 9. In order to get the diffuse number, we have 2 times 2, which is 4. And then we have 4 times 9, which is this number, which is 36. And that's how we end up at this number. If we were to change this number to 3, you can now see that this changes to 81. And this is because we now have 3 times 3, which is 9. And we have 9 times 9, which is 81. And that's how we end up at this amount. This is also why you have to be a little bit careful. In other engines, you might want to just increase the numbers a little bit. When it comes to increasing from 2 to 3, that's not really a whole lot. But in this case, if you see we go from 2 to 3, we go from 36 to 81. If we set now the camera amount from 3 to 4, you can see we now went from 36 to 144. So these are starting to go up quite fast. So let's just set this back to where it was. 3 and then 2. And the way this works is that the camera AA, that this is the general anti-aliasing for the overall scene. So if you, for instance, have noise in your, when it comes to depth of field or general anti-aliasing noise, or maybe motion blur, you have to increase the amount on the camera. If you have diffuse, this is where you will increase or decrease the noise from indirect lighting, global illumination. Specularity is specular noise. Transmission is the noise you have in your refraction. Subsurface scattering will be the noise under your subsurface. And indirect, volume indirect will be from the volume lighting. So instead of just going crazy with random settings, we are going to optimize the settings for each component, which means if we have noise in the scene, we're not just going to keep increasing the camera samples to 10 just because we have general noise. Instead, we're going to identify where this noise comes from, and we're going to reduce it based on that. We'll do that a bit later. For now, we're just going to cover some more settings. Next up, we have the ray depth settings. This is how many bounces you have in the scene. So for instance, you have diffuse. This is set to 1 bounce. That means the light is going to hit once and then it's going to bounce. Specularity, the same thing. Transmission set quite high, and that's how we get these really nice results on transmission. Same with volume as well. In this case, setting this to a value of 1 is perfectly fine, but you might have other scenes where there's a crazy amount of bounce light and you really want to capture that. In that case, you might want to set these settings to something like 5 as a starting point, and then we can go from there. If you want motion blur in your scene, we have to enable that under motion blur. It's very simple. You really only have to enable motion blur, not a lot of other settings you have to deal with. The only thing you have to keep in mind is if you want to reduce the noise from motion blur, we don't have a motion blur control. You have to increase the noise from the camera in order to reduce the motion blur. Under textures, we also have 2 buttons. These will be enabled by default. So these are really annoying if you don't know what they're doing, and really awesome if you do. They're based on the TX format. This is a feature which will create a new texture map from your texture map, and it will scale it up and down based on the needs. Imagine if you have an 8K map on this character and you're rendering at 400 pixels. There's absolutely no need whatsoever to use 8K for that. So what it will do, it will scale it down to maybe a 1K map, and then it will only use that for a render. And then once you need an 8K map, it will render the full 8K map. This means that your renders will dramatically speed up in cases of where you're using heavy textures. In this case, it doesn't matter at all because we're not actually using texture maps. But it's also really annoying sometimes because it also auto-convert textures to TX. Now, this can be great and it can be really annoying. The reason it's really annoying is the way I like to work is I'll input some quick maps into Arnold, maybe from Paint or Amari, and then I'll keep overwriting those maps. But if this is enabled, it's not going to overwrite the maps because it's not going to input the maps I input. So if I input a diffuse texture into Arnold and I keep overwriting that map over and over again, well, it doesn't auto-convert it every single time because it's just the same texture. So I tend to actually work with these off, and then when I'm ready to do the final rendering, maybe I'm rendering a bunch of shots, then I'll enable auto textures as well, or TX textures. So you might see this a lot where you suddenly it just says converting to TX, and in your texture folders as well, you have a bunch of TX files. That's where this comes from. So now that we covered these features, we really know how to get started with Arnold. There really aren't a whole lot of more settings we have to know in order to really get into Arnold. So let's look into how we can denoise our render. Here we have the current render with the settings of 3 and 2 for everything else. Now you can see we have some noise in a lot of different areas, but the noise level isn't consistent. You can see we have a lot more noise on this character than we do on that character. So we have to figure out why that is. And we're not just going to look at the render and this is maybe subsurface noise and this is maybe shadow noise. That's incredibly hard to actually figure out. It's really tricky just to look at this and just intuitively know it. So what we'll do is that we will use a system for this. In the PDF attached, there is a brilliant article which we're linking to from the Arnold help documentation, and I'll give you a quick summary of it here. Essentially, it revolves around using AOVs. We are using some very specific AOVs for this purpose, and through each AOV, we can determine what kind of noise is being caused. So this is diffuse direct, this is diffused indirect, it's specular direct and specular indirect, SSS, and transmission. So let's go through the various one. Let's start with diffuse direct. What this is showing us is the general shadow noise, which means the light samples. We've written this up in the PDF as well, and it's really a checklist you will go through. This is not something which necessarily becomes intuitive. This is really a checklist. Go through this and check the noise. So if this is the light samples, that means we have 2 lights we have to check. First one is the area light, and here we have light samples. I tend to throw in the samples of 3. The same is true for the HDRI as well. Let's select the HDRI and let's select 3 samples. And now we will render again, and we should see a vastly cleaner result than we had before. And there we go. Now you can see that the background is a lot clearer than before. And this is because we were able to see that this was shadow noise because we used the diffuse direct. And through there, we can see there was noise. And if there is noise in this AOV, that means it has to be shadow noise. The next one is diffuse indirect. This will display what noise we have from the diffuse. So in this case, we can see we have some noise around here in the bottom and some general noise in the background. So in this case, we are going to increase this amount. What number you want depends on how clean you want it to be. The cleaner it is, or the higher the number, the cleaner it is, but also the higher the render time. So we're going to be setting this to 4. And now you can see with a value of 4, we have significantly cleaner noise around these areas. So let's go back to beauty, and now you can see that we have a pretty clean render already. Then we're going to look at specular direct. The noise in this AOV will be determined by the light samples, like the one we just looked at. So this looks very clean. There is no reason to increase the light samples at all because this looks nice and clean. let's look into specular indirect. In this case, we are now looking at the actual specular samples, and you can see we have a little bit of noise going around. This one is really tricky to actually diagnose. This could be diagnosed as light samples as well if we're just looking at the beauty, but because we know that if we see noise in this AOV, it has to be specular samples. The way we fix this is we go under specular and we increase this. Let's increase this to 4 as well. And now you can see that we have a significantly cleaner render. Obviously, if we also look at the amount of time it's taken, this will be increased significantly as well. Higher numbers means cleaner renders, but also higher render times. So let's go back to beauty, and now we can just inspect. So in general, the render is a lot cleaner now. But if we look at the subsurface, you can see that we have a lot of noise in this one. So what we'll do is that we'll set the subsurface samples quite high, just so we can make sure that we don't have any noise. So we'll set this to 4 for now and see if this is good enough. And now you can see that we have significantly cleaner subsurface scattering. Let's go back to the beauty. The reason I go back to the beauty is because you can sometimes have subsurface scattering noise, but you can't really see it. This could be due to maybe there being textures on top which obscures it, or it could be because you have really clean specularity. In this case, we still have to increase the subsurface just a little bit so that we just get rid of the very last bit of noise. Set this to 5. So we generally have pretty nice samples for the subsurface scattering now. Let's look into the transmission as well. And there is a little bit of noise, so let's increase this as well. Let's set this to 4. The reason I'm setting this to 4 and not something like more conservative like 3 is just because at this point we just have to get a nice result. We can of course optimize it where we're really debating we could get away with a little bit of noise and then have a slightly faster render times. But in our case, we just want nice, clean, still images. If you're dealing with a production and you have to render out 5,000 frames and it's 4K, then that's a different discussion. Where adding more samples can significantly impact your rendering time by potentially days. So in that case, you want to weigh that up. This is a really effective and clean system, and it means that you're not just willy-nilly throwing in samples here and there. You are methodically going through the entire scene and figuring out what area needs more samples. So to sum it up, Arnold relies more on computer time than human time, which is awesome because now we can quickly get nice clean scenes together, and we will just let Arnold deal with the computation. Instead of us spending days and weeks trying to understand what's going on, we just know higher numbers means slower renders but cleaner renders as well. Everything in Arnold is noise based, which means that the way we clean up our renders is by reducing the noise in the different areas. The sampling is based on the different attributes squared multiplied by the total amount of AA samples, which keeps this very nice and simple. If you want to just get nice clean renders and you don't really want to start to optimize this properly, you can also just keep increasing the AA. If you do that, let's just pause this. If we were to do this, to just set this to 5, you can see that all the other samples will just increase. This guarantees you quick renders. So for instance, if you're going out for lunch or something or leaving it overnight, and it doesn't really matter if the render takes, let's say you're going out overnight, and it doesn't matter if the render takes an hour or if it takes 12 hours, then you might as well just go for it. The way I prefer to do it, I really like to not worry about the render settings. It's so nice if you can just work on a scene, make it all really nice, and then just not have to spend 2 days optimizing the scenes. And this is really, really what I prefer about Arnold.